Hi, everyone. It's my pleasure today to welcome you to the webinar presented by Canadian Water Resources Association. My name is Jody Rutledge, and I'm the Assistant Executive Director here at CWRA and will moderate today's session. Before we get started, I want to point out a few things to make sure the webinar runs smoothly. The presentation will run for approximately 40 minutes and will be followed by 20-minute Q&A. At any time, please type your questions or comments in the questions pane in the GoToWebinar control panel. All these questions and comments will be held and asked on your behalf at the end of the presentation. I've typed a short welcome message to get you started, and we'll be posting links throughout the presentation that you may wish to use for follow-up. If you find today's session insightful, I encourage you and your colleagues to join us again tomorrow for another lunchtime webinar in which Doug Johnson of the Saskatchewan Water Security Agency will discuss implementing agricultural water management strategies in that province. You can go to our website at cwra.org for more info or to sign up. Our presenter today is Professor Howard Wieder, Canada Excellence Research Chair in Water Security and Director of the Global Institute for Water Security at the University of Saskatchewan. Professor Wieder is a leading expert in hydrological science and modeling. He's published more than 200 articles and authored 6 books. He is a fellow of the Royal Academy of Engineering and the American Geophysical Union. He has initiated and led research programs in the UK and in Canada. He has advised state, provincial, and national governments on flood, water resource, and water quality issues. He also leads the Changing Cold Regions Network that is focused on analysis and prediction of hydrological change in Western Canada. In today's presentation, Professor Wieder will discuss the Global Water Futures Initiative, Solutions to Water Threats in an Era of Global Change. It is the largest university-led water research program ever funded worldwide. With additional funding, the total program budget is over $143 million over 7 years. The aim is to transform the way Canadian communities, governments, and industries improve disaster warning, predict water futures, and adapt and manage risk. And with this, I'd like to welcome Professor Wieder and hand the presentation over to him at this time.
Well, thank you very much for that nice introduction, Jody, and it's a great pleasure to be speaking to a large and diverse audience, and not just in Canada, but internationally. So this, I think, is an exciting time for Canada, because we do, as you were saying, have really a major opportunity that's arisen. The Canadian government had a competition for all universities across all areas of science to bid for substantial funding to really do transformative science that was also a benefit to Canada. And we were fortunate to be awarded $78 million from that program. And we also have substantial support from 4 participating universities and the province of Saskatchewan. So it's an exciting opportunity, but one that we feel is appropriate to the magnitude of the challenges that we face. So just to note that I think water is one of the major issues on the global agenda. It's certainly impacting people and politicians and industry. The challenges are many. So we're seeing significant change to the natural environment because of climate change, but also human activities. And here in Canada, there's fairly profound implications of that. We're also seeing a growing population and increasing socio-economic development, which is putting pressure on water systems in terms of water quantity and water quality. And projections globally are for a very substantial proportion of the world's population to face increasing water scarcity by the 2030s and the 2050s. A recent UNESCO report has pointed out that a substantial proportion of the world's jobs actually depend on access to water and water-related services. And of course, our global trade in food and goods depends on water availability. So there's some major challenges in terms of pressures on water resources, on the water environment in terms of ecosystems and on water quality. Those pressures are set to increase. And then in addition, because we're in a non-stationary world, the historical patterns of water availability that we've grown up and used to manage our water environment are no longer an adequate guide for the future. So when we turn to Canada, I think there's been quite a lot of complacency really in the Canadian public, because Canada is a big country and it has a lot of water. But of course, water is a local as well as a regional and national issue, and all the pressures that I've been talking about play out in Canada. So we've had some severe flooding over the last few years. The Calgary flood was notable. So the centre of Calgary was underwater with about $6 billion worth of damage, and also in 2013 there was a major flood in Toronto. We have pressures on water quality, and some of the world's largest lakes are suffering from issues of eutrophication, and that plays out in many respects, not only ecosystems and amenity, but also drinking water. The flip side of floods is drought, and the last major prairie drought was 1999 to 2004, which again caused a $5 to $6 billion impact on the Canadian economy. And the Western Canada has always suffered from droughts, and when we look at the paleo record, we can see that prehistorical droughts were certainly more severe than those that we've seen in the last century. We have issues around source water quality, so issues around organics, and then when we chlorinate them, we have chlorinated disinfection byproducts which are carcinogenic. We have major issues around First Nations communities and provision of safe water. And then we have issues around industry's needs to manage its wastes and society's need to manage its waste. So there's a whole series of challenges that Canada faces. I talked earlier about the climate warming, and Canada in many respects is the canary in the coal mine here, because we're seeing significantly greater rates of warming than the global average, and some of the statistics are quite stark. For example, over the last 50 years, Western Canada has lost snow cover to the tune of 1 to 2 months. So that's a huge change. Winter minimum temperatures up by 6 degrees C. Lots of implications of this. So in the north, we're seeing permafrost thaw, and that, of course, is affecting infrastructure, but it's also affecting hydrological systems in quite subtle and complex ways, including landscape collapse and changing connectivity in the landscape. In the Rocky Mountains, the glaciers are retreating, and 2015 was a record year for glacier retreat. We expect that 70 or 80% of the glaciers will have gone by the turn of the century. Apart from the extremes that I've just spoken about, the floods and droughts, we're seeing changes in flood behavior, certainly in Western Canada, where the prairies have typically seen the major hydrograph peak being spring snowmelt, but in the last few years we've had very significant and quite unprecedented summer flooding. Drought has many aspects. Of course, it impacts water resources, but there are wider issues, and wildfires are one of those. And you'll all be aware of the Fort McMurray fire that we had, but also previously fairly significant fires in Western and Eastern Canada. So really, there's a whole series of challenges, and we need to take those seriously in terms of providing science and decision support systems to handle these. So we certainly need better science to understand the way in which the Earth system is changing. We need new modeling tools to look at the interconnections on the landscape, linking climate with ecosystems and terrestrial ecosystems, hydrological systems, aquatic ecosystems and water quality, but also recognizing the social dimension and the fact that much of our water is water flows are determined by human decisions around management of dams and irrigation systems. We need to do a better job at monitoring, and Canada has a real challenge with its very large areas and sparse population, but there's some exciting new technologies that we can draw on to help us. And then I think more particularly we need to do a better job at linking the science and the user communities so that we can translate scientific knowledge into societal action. This has been an area where I think we've failed significantly in the past to provide appropriate solutions. So our new program really aims to address all of those areas, and the banner headline is really how can we best prepare for and manage water futures in the face of dramatically increasing risks. So the competition that has funded us had two aims. One was to reinforce Canada's role as a leader in international science, and the other was to provide benefits to Canada and the Canadian economy. And so we're well placed to achieve both of those targets. We can see ourselves as a global leader in understanding the water science around the world's cold regions. And by that we mean regions where snow and ice and frozen soils are important, and that's the whole of Canada, but also 50% of the world's population receives their water resources from similar regions. And then secondly, I think there's a need to address the strategic needs that I've just outlined in terms of the Canadian economy. And there's a governance challenge in Canada with very large responsibilities lying with the provinces and territorial governments, and yet those governments have limited population and large areas, so they're really stretched in terms of their technical capability, and there's a need for support. So there are three areas that we're focusing on in this program. One is to do a better job at disaster warning, and that means flood forecasting, of course, and it's a very patchy situation in Canada at the moment, with some responsibilities lying in some regions with Environment Canada, but other responsibilities lying with provincial and territorial governments, and they have quite mixed capability. We see opportunities for improved forecasting of seasonal flows and drought warning. And then in addition, there's a need to take forecasting into the water quality arena and look at the likely incidence of algal blooms and their potential impacts in terms of water treatment technologies. The second area that we want to work on is doing a better job at predicting water futures. So what is Canada going to look like in the 2030s, 2050s, in 2100 in terms of our terrestrial ecosystems, our landscapes, our water systems, our aquatic ecosystems? And we need to do a better job at predictive modeling of the Earth system. And then finally, change is inevitable. How do we adapt to the change as a society, and how do we manage these risks? So we plan to work with quite a wide range of user communities. So we're interested in working with governments, we're interested in working with urban and rural communities and First Nations communities. We're interested in working with industry and agriculture in all its forms. They have some generic needs, but also they have some specific needs, and we plan to work with them to help them to manage the risks. So we have quite a large project. It's led with a grant to the University of Saskatchewan, but we have 4 key university partners: Waterloo, McMaster and Wilfrid Laurier. And each of those partners is providing substantial funding to the program, and much of that funding is to strengthen their institutional capability, but also Canada's national capability. So there will be quite a large number, probably about 18 new faculty appointments made across Canada. We have a grant of $78 million from the federal government, and then substantial in-kind contributions from various sources. We've got obviously a major challenge because we have a large community of scientists to bring together, not just the university sector. I should say, perhaps I'll just go back to that previous slide, that we've got 14 other Canadian universities involved in the program, and we also have 8 federal government agencies involved. So it's quite a complex program in terms of integrating the science and bringing this human capacity to bear on these challenges. And it's also a challenge because we have a large set of user communities. And in fact, we had about 138 letters of support from users for our proposal. So we're organizing ourselves around 3 pillars of activity. And the first is a set of science initiatives around diagnosing and predicting change. The second is moving water into the area of big data, with some exciting developments in not only ground-based sensing but also remote sensing, and then using a range of techniques to provide information to the public and other users, including social media. And then the third pillar is all about designing user solutions. So just to say a little bit more about those 3, diagnosing and predicting change is where we have got some fundamental science to do. So hydrometeorology and climate change is a key part of our program, because we really need to do a better job at understanding climate futures, and in particular what's going to happen to precipitation in a warmer world. We have a program in hydrology and terrestrial ecology to understand the changing dynamics and interactions of those systems and their feedbacks to the climate system. We have a major program in water quality and aquatic ecosystems, looking at water quality in our rivers and lakes and using new technologies to gain new insights. Important part of the program is the social science component, because the humans are increasingly dominating changes to the physical landscape and also dominating water management. So many of you will know Saskatoon and the Saskatchewan River. The water that flows through the city of Saskatoon is determined by decisions made by the government in Alberta and by operation of dams upstream in the province of Saskatchewan. And some of the key decisions around water resources are essentially political. How much water do we leave in a river system for an ecosystem is essentially a societal choice. And then a final strand is to look at some issues around water and health. Concerns are quite diverse, particularly how is a changing climate going to affect future health through extreme events and droughts and associated consequences around fires and perhaps disease vectors. And then how is our changing water quality going to affect drinking water and for both urban and rural communities. So we've got some exciting new developments that we'll be building on. I think one of the really exciting initiatives is the fact that we can move to an era of high resolution atmospheric modeling. And this is a slide that just shows some of our recent work where we're modeling the whole of Western Canada at 4-kilometer resolution over a period of historical period of 14 or 15 years, and also looking at global warming in the 2070s to 2100. And this kind of fine detail can actually resolve precipitation in a way that hasn't been done before. And so we've got some important new insights into high-resolution precipitation, and particularly how it affects mountain hydrology and mountain processes. That's just one example of an exciting way forward, and we can show that the high-resolution modeling is actually doing a better job at matching ground-based observations than some of the smoothed data products, which are quite widely available, like Anasplin, for example. Second key element is about big data and decision support systems, and I think there really are very important opportunities here. Over the last few years, we've developed the Saskatchewan and the Mackenzie basins as very large-scale observatories of the order of millions of square kilometers. So we have nested fine-scale observatory sites, and then we're looking at the basins as a whole, and they're now part of the World Climate Research Programme. We want to extend this concept to become pan-Canadian. We want to develop smart watersheds, such as the initiative that University of Waterloo has in southern Ontario. And then there's a whole area of promise with new remote sensing technologies. So drones are becoming ubiquitous. We will develop a new large-scale coal regions drone platform. And also we have a lot of interest from satellite providers in terms of both forthcoming missions from the major players like NASA, but also innovative initiatives from some of the private sector satellite companies. In the area of water quality, I think that we're on the verge of quite a transformational change by being able to look at eDNA techniques. So we're thinking about how do we fingerprint rivers in terms of eDNA, for example. So some really exciting opportunities around data, and then together with that, we have some exciting opportunities to make information available to a whole range of users, the general public, but also industry, agriculture, communities, governments, and so on. So we've got a vision of a new era of information systems across Canada, from satellites and drones and telemetered ground-based observations using both existing technologies and some new tools that we'll be developing. So I've got a few slides showing some of the stations that we've got at the moment. In the Rocky Mountains, we've got about 51 stations at the moment, looking at meteorological and hydrological processes, and some really exciting new insights from drone technologies, as you see on the right-hand side. So we can look at very high resolution. This is a temperature map from a drone. We can move to fairly large-scale drones, which have got the opportunity to fly active sensors. We've got the opportunity for developing new ground-based sensors, for example, for snow soundings. We've got some exciting developments in terms of taking some of these tools and turning them into high-resolution simulation products. And I'm just showing an animation of a section of the Yukon, which is looking at forecast solar radiation. And you can see the very high detail of the product that we have available through high-resolution modeling. So there's some exciting opportunities around data sensing, but then we have to use the opportunities that new technology is providing us in terms of user engagement and information sharing. So there are several initiatives underway. For example, in our Changing Coal Regions network, which we're running, looking at environmental change in Western Canada, we now have an app, and you can call real-time information down from some of our observatories. So what you see here is an example of some climate data from Saint-Denis, which is a wildlife site just outside Saskatoon. And also we've got the potential to develop mobile apps to assist us in data recovery. We've been working with communities on community-based monitoring, and this includes things like snow monitoring, but also working with communities in the North, First Nations, looking at fish health as an index of water quality, and trying to train trainers for the next generation. So the final part of the program is about designing user solutions, and so we want to work very closely with user communities to identify their needs and then work with them to deliver solutions that are appropriate to those needs. And there's some exciting opportunities about developing new models and also new visualization tools to make this information more readily available. So I think we want to see a new era of warning and public information, for example, through apps and social media. And also, of course, information exchange is a two-way thing, and there are considerable opportunities around crowdsourcing data and engaging people through games and other kinds of apps. So we've already been doing some work along these areas. This is an example of a set of projects that we ran across the Saskatchewan River Basin to understand how people's attitudes and values to water varied across the region. We're interested in collaboration with other universities internationally to use state-of-the-art techniques for decision support, and this is the Arizona State University Decision Center for a Desert City, in which they've developed a water simulation tool so that they can sit down with planners and actually plan out various options in terms of urban development, densification and water management, and look at the implications in terms of water security. So we see this kind of multimedia facility being an exciting new way forward. There's also a need, I think, to frame water problems in a way that's helpful to users, and climate change has been a real challenge for the water community, mainly because there's such a lot of uncertainty in the classical approach. So this diagram shows that what we typically do is take climate models. We know that they're really quite poor at representing precipitation, and so we bias correct them to current climate, and then we assume that those bias corrections apply to a future climate, which is a big stretch to make. We then run those models through hydrological models, which themselves have quite a large degree of uncertainty, particularly for cold region processes, and then water resource systems, and then we look at the performance. So this is a very uncertain cascade of models, and indeed it's often the case that we're not sure whether we're going to see increased or decreased precipitation in the future. So other ways of framing water problems might be around vulnerability assessment. So what sort of changes might we expect in the flow regime, and what sensitivities, what vulnerabilities apply to our existing water resource system. And just an example of this is looking at the South Saskatchewan River in Alberta, which is an interesting water resource system because it's already fully allocated, and yet it's experiencing severe pressures of both agricultural and industrial and social development. So we can project changes to the flows from the Rocky Mountains, changing hydrograph peaks and changing annual volumes, and then we can look at current management practices, and if we see blue, things are fine, but if we're starting to move in the red, then we need adaptive management. And this we can combine with conventional scenarios of change to see where they lie on that vulnerability surface. We can also build models that can be used by a variety of people to explore different futures. And this is just a dashboard of a model of the South Saskatchewan River in Saskatoon. And we've got various sliders, so we can change the flows coming into this system from Alberta, and we could look at the implications in terms of our major water resource, Lake Diefenbaker, and downstream flow delivery to Manitoba. One of the major areas of potential future development is to think about increasing irrigation. So we can increase irrigation area and see what implications that has. Now, if I click on this, yes, we've got an animation. So let's look at the inflow from Alberta. We can change that and look at the implications downstream. And then as a next step, we can change irrigation areas, expand our irrigation, and then again look at vulnerabilities over the historical record, as well as considering climate futures. There's also a need to reach out to the general public, and one of the things that we've been doing is actually developing a play. So this is a play called Downstream, which has been held a number of performances from based on the Saskatchewan River, but from the Rocky Mountains down to Cumberland House in the Saskatchewan Delta. So it plays out scenarios of drought and flood risk, and it asks the audience to participate in voting on appropriate solutions. So it's a nice way of raising awareness and starting to build public awareness of these issues, which ultimately underpins political decision making. So that's a fairly brief indication of the sort of challenges and the rather ambitious plans that we've got. We are in the early stages of this award. It was publicly announced in the middle of September, and so we're very busy trying to organize our internal governance, because we've got 4 partner institutions, each seeking to expand their capability, and then we've got 14 other partner universities and 8 federal agencies who will be part of the research team. And then, in addition, we have to connect with our user communities. And right at the moment, we have 4 consultants who are following up on our letters of support and trying to give us a preliminary picture of the sort of priorities and concerns from the user community, so we can focus our first calls for funding. I know there's 1 or 2 people internationally on the call, so I've focused a lot in this talk on Canada, but we are very interested in global outreach for this program and global engagement, and we're linked to a number of universities and research institutes in Europe, the UK, which is still within Europe, Australia, China, and India, and South America. And we lead, for example, a global network for UNESCO and the World Climate Research Programme that links the cold alpine regions together. So we're taking a leadership role in various international initiatives. We're also working with international partners, and as the program matures, we expect to have joint projects in India and China and also South America. So it's an exciting time, and things are very busy here as we try and organize ourselves to make sure that we really do justice to this very substantial funding opportunity and fund substantive programs which are really going to make a difference for Canada and the world. So thank you very much for your kind interest and attention.
Thank you, Professor Weider. So at this time, I'd like to ask the audience to type any questions or comments they might have. I will give you a couple of moments to do that. And I guess in the meantime, Professor Weider, I'm wondering where people can go to access the latest information on the smartphone apps that you described earlier. When or will they be publicly available?
Okay, so on the bottom of this slide is our website for the Global Institute for Water Security. And if you go into links on data there, you can connect with the sort of information systems that we have available. And then also you can connect with the website for Global Water Futures. Mm-hmm.
Great. If our audience members are interested in getting more information on the content of today's webinar, is this the best place to go? Can they contact you?
I'd be pleased to hear from people. This is our major web. I realise I haven't got the Global Water Futures website up here. We do have a website. If you Google Global Water Futures, it will connect you to our website. But the easy way of getting in there is from usask.ca/water, and then that will lead you there straight away.
Great. I was able to put up the link for the Global Institute for Water Security a bit earlier, so people can certainly click on the link there and check that out as well. So we have our first question, and the question is, where do you think that private industry can fit into your initiatives?
Well, we're very interested in working with industry, and industry, of course, has diverse forms and diverse interests. So at one level, we're talking to industry that's involved in advanced technology and computing. So just last night, we were meeting with IBM, for example, who are a supporter of our program, and we have strong links with companies in the information sports systems arena, like aquatic informatics, and then some of the satellite providers like ComDev and Exact Earth. So we're engaged with the sort of big data community. We're very interested in working with hydropower utilities, and we have letters of support from them, and we'll certainly be engaging with them. We are interested in working with extraction industries, so we have current work on with oil and gas companies and the oil sands companies on some of their issues around the management of water and wastes and use of alternative sources of water and issues of disposal. And we're also interested in issues like legacy wastes, including some of the nuclear legacy waste sites that Canada has. More generally, I think the financial sector has got an increasing concern about water risks, and we're looking for ways to connect, and we have a link with PricewaterhouseCoopers at the moment where we're exploring connection to some of their global initiatives. We also have links with the insurance industry, which at the moment has got more of a focus on flooding risks associated with non-fluvial floods because of the way liabilities are managed in Canada, but we certainly are very interested in looking at risks from fluvial floods and trying to develop improved risk assessment to support risk management there. So there's a wide range of industry players, and what we obviously put this proposal together with a set of initial contacts from our partner universities. We are very interested in other people who would be interested in participating in our program. And I should say that although it's quite a substantial program and our grant is $78 million, it is over 7 years, and the demands for and the needs of the program are going to far outweigh the resources that we have available. So we're very interested in building partnerships to work together with industry to address some of their problems.
Great. Next question, is there more information on the health and water aspects?
Not at the moment. It's early days. We've been taking advice from Health Canada on their concerns, and it's also worth noting that at least three of the university partners are seeking to make new faculty appointments in the area of water and health, because it's an area that's not got a lot of strength within the university sector at the moment. The sorts of issues that we see being addressed are issues around future climate and flood risk and drought risk. And drought risk has a whole variety of different implications in terms of human health, and not least, for example, disease vectors. So there's issues around future climate, and we'll be developing a program in that area. There's also issues around water quality and its implications for water treatment, and there's a lot of concern across Canada about increasing levels of dissolved organic carbon, and the fact that when you put that through conventional treatment technologies, you come up with a range of disinfection byproducts which can be harmful to health. So that's an area that we also want to look at. And then there's quite a bit of work going on already in the arena of First Nations and drinking water, and there's a lot of societal issues there, but we're also very interested in helping to inform that debate through better understanding of current and changing raw water quality.
Great. The next question comes from the International Joint Commission. Are there plans to coordinate with research activities in the US?
That's an interesting question. Well, we have some important collaborations with the US, and we're doing quite a lot of work with NCAR, National Centres for Atmospheric Research, and some of the high-resolution modelling that I showed in the presentation was something that's grown out of collaboration with that group. They are also supporting the National Water Centre in the US, which is taking a lead role in flow forecasting. So we're very interested in discussions with them and looking for collaboration. We have quite strong links, and we exchange staff at sort of modelling meetings and strategic discussions. We have been giving advice to the US in terms of cold region processes and modules to represent those. What we would, I think, ideally like to see is much more modularity of modelling tools between the US and Canada. So that's certainly something we're keen to pursue. We would very much want to work with the IJC, and there are many areas of interest, and of course we also are interested in working with some of the other trans-jurisdictional basins, the Mackenzie Basin, the Prairie Provinces Water Board, and so on. The Great Lakes is obviously one area of important focus.
Great. You touched on it a little bit before, but here's another question that you might want to elaborate on. It says, is there a component in the program that addresses First Nation drinking water quality and how this may be influenced by source water quality?
There will be. I think that we, within the program, are not able to go into treatment technologies, but we are very interested in better understanding source water quality and looking at threats to source water quality and coming up with better tools to manage those, looking at better models of our major basins where we have First Nations as downstream users, and then looking at future developments. So I think our area of impact of contribution is mainly going to be in the area of raw water quality, current and future, and the risk assessment associated with industrial developments.
Great. Next question. I live in northern Alberta in the Peace watershed area. Many people up here don't believe in climate change. How can you reach these people with these pressing water concerns?
Well, yes, it seems to me so remarkable that that Canada is experiencing such rapid warming and rapid change, and that there is still quite a resistance in public parts of the public to acknowledging this. I mean, you just have to look at the changes to the glaciers in the Canadian Rocky Mountains and the sort of permafrost thaw that's taking place in the north, and of course changing Arctic sea ice to see this playing out. So, well, I think as I tried to indicate in the talk, there are various user communities that we need to reach, and certainly the public is one of those, and we're trying to make information available. So For example, we're running a network called the Changing Coal Regions Network, which you can also reach from our website, and that's looking at environmental change in Western Canada. And we produced some briefing documents, some 2 pages that can be used for public dissemination, which actually explain how temperatures changed over the last 50 years and the changing patterns of snow and rain, and the declining snowpacks and the reducing glaciers. So we're working at, so that's another program that we're running. It's a 5-year program, just about to come into its 5th year. And so we're really trying to focus on information products. So if you look at CCRN, then you'll see we've got some information that is really targeted at more of the general public. And then we do quite a lot of work with the media. So we've been doing both TV and radio, particularly my colleague John Pomeroy has been very proactive. So we try and take opportunities as they arise. It's interesting because we just had an annual meeting of CCRN, and we've been reflecting on the various extreme events that we've had over this last 4 years. So we've had the Calgary floods, we've had the major wildfires, and we've had the drought. And our climate scientists advise us that in each of these natural disasters, there's at least one component which is enhanced by climate warming. So I think the extreme events that we've been seeing in the last decade are sort of part of the manifestation of climate change.
Great. Now a comment from a representative for Keepers of the Water Council. They comment, very interesting. We are involved in connecting traditional ecological knowledge holders with Western scientists. I hope that you connect with Dr. Clinton Westman at U of Saskatchewan regarding the difficulties in access for First Nations.
Well, I think we're doing quite a lot of work currently with First Nations. I don't know that person. So we have a First Nations water and health program led by a lady called Anita Bardwaj, which is doing some really interesting work with the First Nations in the province to do with their drinking water challenges. And then we have a couple of programs engaging with First Nations further north. So one is called Delta Dialogue. So we're working with First Nations in the Saskatchewan Delta and the Peace Athabasca Delta, Slave River Delta, in a whole range of issues, including community-based monitoring programs. Our Changing Coal Regions Network has a very strong partnership with the Northwest Territories government. And again, there's quite a lot of work going on there in terms of interacting with First Nations communities. So we're not doing as much as we expect to do under the new program, but I think it's an area that we take very seriously and is high on our agenda.
Great. Next question. How do you plan to navigate the responsibility of forecasting with the provinces, territories, and federal government?
Well, that's a very interesting question and a very insightful one. So at the moment, we do a lot of work with Environment Canada, and we have a joint modelling team of about 20 people that's seeking to enhance their capability for large-scale modelling. So we're working with the kind of models that they use for weather forecasting and also modelling future climate, and we're working with them to enhance that capability. Under the new program, I think we'll be able to take a more proactive role. So right at the moment, we're working with Environment Canada, who are of course run forecasting systems in the Great Lakes Basin, but not currently in the West. And so we're working with them to trial their forecasting system over the southern Saskatchewan Basin, and we envisage working jointly with them to develop tools for flood forecasting, and similarly working with their seasonal forecast group in the West to enhance their capabilities. So we're certainly looking at building partnerships, and I think we we're not entirely clear how a product would roll out, and that's a matter for discussion. At the moment, we're starting to, we're planning how we will improve the capabilities so that we have a product that can be delivered. The precise mechanism of delivery is unclear. There also are some bilateral discussions going on with various provincial governments about how we might be able to assist them in terms of developing improved local scale for flood forecasting systems.
Great. Next question. Considering the finite period of the funding and the fractured nature of water management in Canada, how do you plan to ensure that the products of these studies will be adopted by agencies and funded beyond this effort?
I think that's another very good question. I would say that we're sufficiently big as a program to attract quite a lot of national interest. And so we've already sort of started to have some preliminary discussions with federal government about how we might assist in moving towards what might be a national water strategy. I think certainly there are some really important governance issues that need to be tackled, and while it's not our role to address these, we can certainly help to support initiatives that move forward in that area. As far as the 7 years is concerned, there's quite a chunk of funding coming into this program from the 4 partner universities, who will be appointing up to 20 new faculty, actually about 18, I think. And they, of course, are permanent appointments. So we will be, the universities will be continuing their commitment to research contributions in this area. I couldn't really speculate at this stage what would be available to follow on from this initiative.
Great. Do you plan to be working with hydropower companies in Canada and abroad for water resources, for instance, water resource issues?
Yes. So we are certainly very interested in working with hydropower companies in Canada. We haven't really thought too much about hydropower companies internationally, but we'd be very open to ideas in that area. I mean, we certainly have got fairly active engagement in South America, and there's joint research going on in Chile at the moment, and we're talking about joint work in India, in the Himalayas, and also some work in China to do with the Tibetan Plateau. But we've been very open to suggestions.
How is the Paris Agreement changing your modeling work?
Sorry, could you repeat that question?
Sure. How will the Paris Agreement change your modeling work?
Well, I don't think the Paris Agreement will change our modeling work. I mean, I think that there are very immediate societal needs which are very clear, to do with understanding future change and adapting to change. We don't really propose to do a lot of work in the area of mitigation, although it's feasible that we might do some work in that area. But you know, we're of course really supportive of these issues. But if you look at climate change projections, then you'll find that you know, the die is cast in terms of the next few decades, and the different scenarios up to the 2050s don't diverge that much. So we're in a situation where we do have some severe needs for adaptation, and that is our major focus. But of course, we're very keen to raise public awareness of these issues and inform mitigation.
Have there been efforts to discuss collaborations with the NSERC Create H2O program for First Nations water and sanitation security, involving the University of Manitoba, Trent University, and the University College of the North?
No, there haven't. But that doesn't mean to say that there shouldn't be.
Great. Maybe we can get the two groups in touch.
Yeah.
With needs outpacing resources, will the GWF coordinate with other research groups, in particular FloodNet, to limit overlap and to build upon other recent or ongoing research?
Yes. So we certainly hope to connect with FloodNet, and we have a number of members of our partnership who are common, not least the lead PI on FloodNet, and also I think the chairman of the board of directors. So this is something that we're aware of and would want to, as you say, work to. We don't want to compete with existing initiatives. We really want to mutually strengthen them.
Great. And almost as a follow-up question to that one, I'm from a watershed group in Alberta. I see that there are a couple Alberta watershed groups that are your partners. What does it mean to be a partner in this project?
Okay. Well, in the first instance, it meant somebody writing us a nice letter of support, which explained what their needs were and how we might jointly work to address them. I recognize that although we kind of reached out, and I said we've got about 138 letters of support, this is sort of the tip of the iceberg in what we could be doing. So we are interested in reaching out to other groups, and if people are interested in being involved, then please let me know, and we'll see what we can do to follow up.
Great. Just a couple more questions to round out the hour. How many climate change scenarios are you working on for water forecast, or is it only focusing on Western Canada, prairies, or the entire country?
Okay, so let me just be a little bit clear. I came to Canada in 2010 as something called a Canada Excellence Research Chair. And at that point, I had $30 million of funding from the federal government and the province of Saskatchewan and the university. And that allowed me to build a program which ran across disciplines and was largely focused on the Saskatchewan River Basin. Later on, a couple of years later, we were successful in developing a Western Canadian network, which is called the Changing Cold Regions Network, CCRN. And that brings together 8 universities and 4 federal agencies. And that's looking at the interior of Western Canada. So it's the Saskatchewan and the Mackenzie Basin from the southern US border up to the Arctic. And that's been the focus of the work that we've been doing up to now. That program has another year to go, and we're starting to deliver products which are really focused on Western Canada. The new program is pan-Canadian, and we're really in the early days of this new program because I say it was announced in mid-September, and so we're just getting our act together in terms of putting the governance structure, trying to decide what our immediate priorities are, and starting to move forward on some of these exciting new data developments. So it's early days, but the focus for that will be pan-Canadian. In terms of Western Canadian products, we already have some quite interesting work because we do have global warming scenarios which we've just finished producing for the 2070s to 2100 using a 4-kilometer high resolution atmospheric model. And we're also in discussion with the 2 Canadian regional climate modeling groups about linking in with them for scenarios of change. And so this CCRN, I say, it's entering its last year, and we will be looking at a range of products, which I think includes the 2 Canadian two Canadian regional climate models and the high resolution WRF model, and that will inform development of some large-scale modeling of those river basins and how they will change under future climate, and also what will happen at the small scale, focusing on some of our observatories. and we're looking to deliver products from that sort of this time next year.
Great. Keeping with it tight to the hour, looks like we got addressed most of the questions. If anyone would like to have some follow-up questions or comments for Professor Weider, you can contact me directly following the follow-up email that will come out in the next couple of days. So I would just like, CWRA would like to thank Professor Weider, the University of Saskatchewan, and the Global Institute for Water Security for his time and contributions. And of course, thank you to everyone for attending today.
Thank you for the invitation.
Great. A follow-up email just for some information will be sent out that will contain a link to the download file of the PDF of today's slides. That will come out in the coming days. And if you missed something or would like to share this webinar with colleagues, the link to the recorded version will be posted on our Twitter account and in our CWRA newsletter. Thank you, everyone, and have a great day.